Solved problems. First problem. Which assignments satisfy the formula that exists y, left parenthesis p0x, and p1y, right parenthesis. In the below unary structure, we are given a picture of the unary structure. There are two unary predicates, p0 and p1, which intersect each other, and then there are some elements a, b, c, d, e, f, g in the universe. And we are given three assignments, S0, S1, S2. We have to go through these assignments and check in each case whether the assignment satisfies the formula in the given structure. Let's look at S0 quickly. S0 gives x value c. Intuitively, this formula asks, is it so that we can find a value for y which satisfies p1, and at the same time the value of x satisfies p0? So let's look at p1. What is in p1? A and f. Well, so we should try a and f. Let's try f. F satisfies p1, and if we have an assignment where x satisfies p0, then we are okay. In S0, the value of x is c, which is in p0, so that's fine. And if we interpret y as f, then also p1 is satisfied. So S0 seems to satisfy this formula. In S1, the value of x is a, which is also in p0, so we are doing fine. And we can give y again the value f, which is in p1, so again we are fine. In assignment S2, the value of x is e, and e is not in p0. We can't do anything about it. Whatever value we give to y, it's not going to make p0x true in this assignment, so S2 is not going to work. It does not satisfy this formula. Let us look at it a bit more carefully now. Let us first show that S0 satisfies a given formula in M. The modified assignment S0f/y satisfies P1y in this model, as f is indeed in P1m. The assignment S0f/y satisfies also P0x in this model, as the value of x in this model, namely S0f/y in x, equals c, which is in P0. So S0f/y does satisfy P0x and P1y in M. Hence, S0 satisfies the given formula. There exists y, left parenthesis P0x, and P1y, right parenthesis, in M. Next, we show that S1 also satisfies the given formula in M. We already observed that S1f/y satisfies P1y in M. The assignment S1f/y satisfies also P0x in this model, as the value of x in this assignment, namely S1f/y of x, is a, and a is in P0m. Hence, S satisfies. There exists y, left parenthesis P0x, and P1y, right parenthesis, in M. Let us finally show that S2 does not satisfy the given formula in M. Whatever element h we pick, the modified assignment S2h/y fails to satisfy P0x in this model, as S2h/y of x equals e, which is not in P0m. So S2h/y fails to satisfy P0x and P1y in M, whatever h is. Hence, S2 does not satisfy. There exists y, left parenthesis P0x, and P1y, right parenthesis, in M. So the answer is the first two assignments satisfy the formula in M, and the last one does not. We can write the whole solution also using the notation M satisfies sub S A. Then, in order to show that S0 satisfies, there exists y, left parenthesis p0x and p1y, right parenthesis in M. We first note that S0 f slash y satisfies p1y in M, as f is in p1 M. We also note that S0 f slash y satisfies p0 x in M, as S0 f slash y in x, which equals c, is in p0 M. So S0 f slash y satisfies a conjunction p0 x and p1 y in M. Hence, by the truth definition, S0 satisfies there exists y, left parenthesis p0 x and p1 y, right parenthesis in M. Next, we show that also S1 satisfies the formula in M. We have already observed that S1 f slash y satisfies p1 y in M. We note that also S1 f slash y satisfies p0 x in M, as S1 f slash y in x equals a, which is in p0 M. Hence, S1 satisfies there exists y, left parenthesis p0 x and p1 y, right parenthesis in M. Let us finally show that S2 does not satisfy the formula in M. Whatever element h we pick, S2 h slash y does not satisfy p0x, as S2 h slash y in x is e, which is not in p0m. So S2 h slash y does not satisfy p0x and p1y in M, whatever h is. Hence, S2 does not satisfy there exists y, left parenthesis p0x and p1y, right parenthesis in M. So again, the answer is that the first two assignments satisfy the formula in M and the last does not. With these slides, with the title The Same Proof, Different Notation, we can see how one can argue symbolically about quantifiers and assignments. Previously, we argued verbally. Now here is a more symbolic presentation. This more symbolic way of writing is very handy when one gets used to it, but of course it needs some practice to get used to this notation. Next problem. Which assignments satisfy the formula p1y implies for all x, left parenthesis p0x implies p1x, right parenthesis, in the below unary structure? Again, we have two unary predicates p0 and p1 and some elements which are in p0 or p1 or in both or in neither. And we have three assignments S0, S1 and S2. The formula we are considering is an implication. An easy way to satisfy it would be to have the hypothesis false. So if we have an assignment which gives y a value which is not in p1, then the implication is certainly true. S0 gives y c, and c is not in p1, so S0 certainly satisfies. S1 gives y the value a, which is in p1, so we can't use this easy trick. We have to look at the conclusion also. The conclusion says that every element of p0 is in p1. So it doesn't talk about y or, in fact, not of any variable, particularly because it doesn't have any free variables. So let's look at the picture. Is p0 a subset of p1? No, it's not. So with S1, the hypothesis is true but the conclusion is false, so S1 does not satisfy the formula. Finally, S2, y gets the value e, which is not in P1. So again, there is an easy solution to the question whether S2 satisfies the implication. It satisfies the implication because it doesn't satisfy the hypothesis. Let us now look at the proof in a little bit more detail. The formula we are considering is an implication. Implication is true if the hypothesis is false. The value of y in S0 and S2 is outside the set P1 M. So both S0 and S2 fail to satisfy P1 y in M, hence they both satisfy the given formula. We are left with S1. In this case, S1y is A, which is in P1M, so the hypothesis of the implication is true. We have to next consider the conclusion. The conclusion says intuitively, as we remarked earlier, that P0 is contained in P1. But this is clearly false. Let us see why it is clearly false. Well, because, for example, C is in P0M but not in P1M. So S1C/X fails to satisfy P0X implies P1X. Hence S1 fails to satisfy for all X, left parenthesis P0X implies P1X right parenthesis. Hence S1 does not satisfy the given formula in M. So the answer is that the first and the last assignment satisfies a formula in M and the middle one does not.